I'm happy to get a chance to talk about this. Something that I've been waiting for about 2.5 years now finally happened. AWS finally came out with a way that I can write code that makes infrastructure instead of writing configuration files that makes infrastructure. So I'm really excited to talk about this. But first, I should probably say my name is Ribeiro, and this is my talk on the AWS CDK and also an introduction to infrastructure as code. So a little bit about me. I'm an AWS certified DevOps engineer, as well as certified developer. I work for a company called Track 10. We are an AWS focused consultancy. We help companies that know a lot or nothing, and anything in between about AWS get going, get better, or make sure that they're top notch. Everything from security to building out serverless projects, IoT, all kinds of stuff like that. I'm a IUSB graduate from their master's in applied math and computer science program, and my favorite language is JavaScript. So once again, like all my talks, it's all JavaScript, baby.
But don't bury the lead. The better part is you also went to Purdue.
I did also go to Purdue. Has nothing to do with what I do now, though. I had a lot of fun. Alright. So let's talk about some super important background stuff. Brief history of repeatability. So something that has become a bigger and bigger deal. In fact, now we've even come up with a term for it. We call it DevOps now. But the bigger and bigger thing nowadays is making things repeatable, making things automated. And we started out, people wrote scripts of stuff to deploy things. Then we started doing unit testing and other automated testing. And linting, because we actually thought style mattered. We have to read this stuff. But so we started to do all these kinds of things. Then we got build. Just even build tools are actually probably the oldest thing in this list. Compilers and things like that. Turning code into something we can actually execute. So we've automated all these things, and then we eventually had systems like, well, hey, when we check this stuff in, let's just make it happen. Drinking hard seltzer while you're doing a presentation, that's the worst idea. Just realizing this to regret it. And then we realized we could make that configuration for CI/CD into code and check that into version control, and everything was amazing. But cloud workloads require infrastructure too, and why not make that repeatable through code? We have APIs, SDKs, CLIs. So there's any number of ways that we can trigger these things to exist that doesn't involve clicking a mouse around on a web console. What about that? Well, that's a thing. We call it infrastructure as code. The idea is to programmatically define compute, storage, network, security, and other resources. Big pieces about this, reducing drift. So if you have a dev environment and a QA environment and a prod environment, you shouldn't have things that are unique about each of those environments, because somebody had to go in and, well, I'm gonna tweak this. Well, now that doesn't, what worked in dev may not work in QA, may not work in prod, or prod may be special now, and we have to take these other things into consideration. Those become snowflake environments. So reducing drift, preventing snowflakes, that's a big component of looking at infrastructure as code. Idempotence, the idea that you can deploy this thing over and over and over, and it's not going to stomp all over the things you just deployed, because it's just making sure that the stuff that you want out there is there in the state that you wanted it. And then it becomes versionable because it's code, so it's it's something that's text, it's bytes in a file that can be checked into a version control system. It can be looked at over and over. You can roll it back, roll it forward. And in terms of options, every major cloud provider has some format. Since this presentation focuses on AWS, I focused on a couple of different tools they have. The official AWS blessed things are really all centered around CloudFormation. SAM, serverless application model, we'll talk about that a little bit, was an extension to CloudFormation, and the CDK is really the focus of tonight's talk. The community's also designed things that basically either boil down to CloudFormation or invoke various API, and SDK calls. Troposphere is one of those. On Azure, there's Azure Resource Manager. GCP has their Cloud Deployment Manager. And then for people who want to be multi-cloud and hate their lives, there's things like Terraform. Actually, I don't pick on serverless in this realm here. I'm a big fan of serverless framework, but they do embrace kind of a multi-cloud approach. Although most stuff really tends to be, you get into doing anything serious with it, you end up kind of nailing yourself into one of the cloud providers anyway. But there's also config management tools, things like Ansible, Salt, Chef, Puppet. All of those are capable of standing up resources in cloud providers and things like that. But this talk is really focused on AWS blessed things and then what's come out of there. Particularly because the CDK just went, came out of beta and is now generally available. So we'll talk about infrastructure as code in AWS. So CloudFormation is what we've had for years. The idea here is it's declarative JSON or YAML describing our infrastructure. So by that we mean we're not saying do this, then do this, then do this. For the most part, you basically say, here's the things I need, and it figures out because maybe some S3 bucket over here references something over there. Well, we have to build that thing first so that the S3 bucket can actually reference it. If you happen to make a cyclic dependency or a chain of things that become a cycle, it breaks and it yells at you, and then you just break the cycle and you keep going. Common terms here, so we have kind of a concept. There's concepts of templates and stacks, and I like to make those an analogy to classes and objects. The template is, or if you're a big fan of Docker, the difference between an image and a container. You have the idea or the description of something, and you have the actual instantiation of something. Template describes what infrastructure I want. A stack is the actual deployed implementation of that. There's actual real resources backing that. You can tear down whole stacks though from the console, CLI, SDK, etc. Supports things like passing in parameters, so you can customize things like bucket names or CIDR ranges or whatever it is that you need to customize. Conditions, that you can turn things on and off based on those parameters or other things. You can have multiple stacks that can reference, this stack can reference something coming out of that stack. Macros, custom resources. Custom resources are, well, we don't have something that quite does this. Well, as we're standing up this stack, let's actually just run some code, and when it comes back, we're done. Nested stacks, so a stack that has more than one stack inside of it. And there's even all kinds of other constructs they've come up with. Things that it's lacking, though, that when you really get into the weeds with it, that become a little bit painful. On the YAML side, anchors and aliases, if you're familiar with what those are, you already kind of know why those would be useful. For those who aren't familiar, the idea is basically you can say, I have this chunk of YAML, I want to use it kind of as a template and inject it into these other spots. And it'd be really great if I could do that when I need 3 subnets. I just want to write it once. It's like the same thing every time, except for one little thing. Iteration would be great, if I could, for 3 subnets, just iterate this one thing. Whatever it is that you're doing, though, there are times where it's being able to template pieces of your template, or to iterate values, or maybe even have better conditional logic. I mean, the conditions in CloudFormation are somewhat limited. And Boolean values even here are represented as strings, so we can't even pass in proper trues and falses, it's all strings. So I want to show you guys an example of some CloudFormation. This just stands up an S3 bucket that I keep all my memes in. It's 2019, everybody's got to have a meme stash. So pretty simple, stands up a meme bucket, gives it a name, memes, and then we substitute in some variables, the AWS region, the current account ID. For those unfamiliar with S3, bucket names must be globally unique, so including your region and your account ID is a pretty sure shot that nobody's used it, hopefully. It'd be really weird if somebody else used your account number and a region name, I'm just gonna mess with them. And then it actually outputs, so we can actually see in the output when this thing's been done, the actual bucket name. We could add an export to that and make it available to another stack, but This is just a simple example. And then AWS SAM, the serverless application model, was basically taking CloudFormation and extending it with some macros to make it easier to wire up Lambda functions, API gateways. Basically, instead of having to declare a Lambda and its its permission model and a few other things, like you just have the resource type is AWS serverless function instead, and so you just declare that. You give it the right things, and the SAM CLI was able to pack everything up, pull in all of the dependencies, do everything that needed to be done, and do it right, and push it all up. But it's still CloudFormation at heart, so it still has the same complexity to learn. We all know, well, I think pretty much everyone here knows at least one programming language, probably a couple. So as long as you know one of the, this is different than that though. Even if you know JSON or YAML, this is, those are just ways to describe data. You actually have to learn a whole structure, a whole way to put this stuff together. I mean, even now after 2.5 years of doing this, I still go back and look at the docs when I'm, trying to remember how to put a trigger on an S3 bucket or whatever. There's so many properties on each one of these entities, and you have to know all of the details and get them all right, or CloudFormation is just going to yell at you. So there's complexity involved, and you don't get away with it. Get away from it with SAM. So I'm not saying you necessarily get away from complexity at all with the CDK, but I think it provides a different option. So now we're moving to something that's imperative code describing infrastructure as an application. We can even have more than one stack in an application. This changes the paradigm from which we look at how we're going to assemble infrastructure, how we're going to group it, how we're going to work with it. All of it still compiles down to CloudFormation templates though, so we're not running away from it, we're just augmenting how we put it together. We get all the benefits of CloudFormation then, but we also get all the benefits of code, iteration, custom modules and packages. We can organize our code into multiple files. We can structurally organize this, like you would any other piece of software. Actual Booleans. I'm sorry, maybe I'm the one who actually gets excited about the idea of not having to use strings when I mean true or false. I don't know. And then there's still higher level constructs like SAM's macros. So we can there's instances. I'm going to show you one where code that fits on one slide generates 500 lines of CloudFormation. If that gives you an idea for the high level constructs that we're talking about. I mean, huge amounts of resources just generated out of a little bit of text. Has its own CLI for deployment, compiling, stack management, and a number of other functions. And language support, TypeScript and JavaScript through Node.js, Python, those are all officially fully supported and generally available, with experimental beta support for Java and .NET Core. This is AWS's own documentation, like what they consider the advantages, so some of this is a little bit redundant from the last slide, but being able to use logic when defining infrastructure, object-oriented techniques, using high-level abstractions and being able to package them, share them, publish them to your team or community. One of the things that really stands out to me about this is, what we're going to see here is like, okay, so this is code now instead, like actual code that could define an S3 bucket. Well, what if I made a package for my company that said, this is how we're going to make S3 buckets. So instead of just grabbing the generic package, now we're going to use our set of packages. We're going to have enforcement. We're going to make sure that they're all encrypted. We're going to make sure that they don't allow for public access. We're going to make sure they don't do bad things, don't follow bad practices. With code, we can enforce all kinds of stuff. Because if people try to violate it, we're going to throw an error. And then if we're doing other good things with automation, like CI, if an error is thrown, the thing never builds, and nobody can ever release it into the world. So, you can actually organize, like I've said before, into logical modules, which can be, you can actually have a nice project organization structure. Here's all the stuff that's related to serverless stuff, and here's some of the stuff that's related to all of my S3 stuff. You can actually organize these things into structures that actually make sense, that a developer can go, wow, this is nicely organized instead of one big long file. Mike knows what I'm talking about. Way back in the day.
Oh, yeah.
What was that? What was it that had 6,000 lines?
Oh, man. I know what you're talking about.
Was it,
PGSLD?
or was it Turnkey?
It might have been.
Anyway. Yeah. So getting away from those, hundreds and thousands of lines in a file. Being able to use actual unit testing practices. You could actually unit test infrastructure as code. Kind of mind blowing. And even things like code completion within the IDE. So things like TypeScript and other more strongly typed languages are going to be able to derive the types from these things and have code completion. You're not getting that out of YAML. You're not getting that out of a lot of things. So we looked at that meme bucket. Here's the meme bucket in the CDK. We're going to go ahead and extend the stack class. We start the constructor. We execute the super. We make a bucket. We have to know. I know that this is a very confusing word, especially in JavaScript. But in this case, unintended, I guess. This refers to the current meme bucket stack being constructed. So each resource that we're creating needs to know what it belongs to. So the first thing you give it, that's what's referred to the scope. And the scope for the bucket is the stack. And then we give it some sort of identifier. The identifier has to be unique within the scope. And then after that is what they call props. These essentially become immutable after construction, but you can give it things like, this is basically configuring it the way you would with any other infrastructure as code. So I can name things, I can configure encryption, I can configure versioning in the case of S3 buckets. Whatever the properties of the resource that you're trying to create are, that's where those go. And then we have that output. I can create a CloudFormation output, and it gets the bucket name as well as the description as before, and then that gets exported. Now, if you're familiar with Node.js, this is not a complete app, this is just a module. So there's still a skeleton that we talked about this being an executable app. Here's that core skeleton, pulls in the core, pulls in the stack, the module I just showed you. We construct an app, and then we actually say, okay, we're going to create a new stack. Its scope is this application, and when we deploy it, the name we want to give it is meme bucket stack. So if I just deploy this, I should see a CloudFormation stack named meme bucket stack. So let's do it. So I have So I have that exact same code up here on screen, and if I can find, there's that, this is way harder to use when you have like huge fonts. Alright, so there's that same skeleton, so I put a slash in there. Alright. So, actually, one thing I'd like to show you guys first is CDK send. So I can tell it to just go ahead and build me the CloudFormation that it would actually build. And gosh, that looks a lot like what was on my slide before. It's a few extra pieces that they added in, but there's that bucket name, and there's the bucket with the bucket name, and we find the output. There's that meme bucket name with a description and a value, and it's actually referencing the meme bucket up above. So let's CDK deploy. This actually goes out, creates CloudFormation change set, and one of the things I really like about their CLI that they did here is it actually has really great looking output. It's rare that you see a CLI that actually looks good as it's doing its job. And it's like, oh, I can read that, it makes sense. It almost looks like that web interface. And yeah, I mean, you can actually see the events stream through, what's happening, what's being created, you know, what happened in the end. And if I go out to CloudFormation, there's my meme bucket stack. I can even go and take a look in the S3 console. There's my memes bucket. Wow, such bucket. I'm glad that reference was received well there. Some people know, some people at least know where I'm going with that. Alright, so anyway, proof of concept, managed to do exactly what we said we were going to do with it. So let's back up and talk about some essential concepts. We've talked about the application. This is an executable application that can then build stuff. And we start as the core concept of what gets built are stacks. So as we've already talked about, CloudFormation has this concept of stacks that contain various infrastructure components. So apps are made up of stacks. Stacks are made up of then pieces of infrastructure, which in this case the CDK refers to as constructs. So these are those various classes. The S3 bucket is a construct. Lambda has a concept of a function that we'll look at in a little bit. That's a construct. There are also higher level constructs, like I'm going to show you, I think it's one of the next few slides. I've talked about the one that generates 500 lines of CloudFormation. That's a higher level construct that spits out way more than just one resource. It's spitting out a lot of things. But you also have, at the same time, there are things that, if for some reason something's not available as a higher level construct, they're still pretty much close to the raw CloudFormation resources, and those are constructs as well. So any of these then get attached to scopes. They have an ID, and they have props, which are the properties that we would normally define in CloudFormation. So the other thing that's important to note is that the core module contains the app class, the stack class. For those familiar with CloudFormation, there is a set of what they call pseudo functions that start with fn, and with those you can grab attributes, you can do sort of string concatenations and things like that. And so those are all available in the fn class. We still have outputs, which were a property of CloudFormation, conditions, so our CFN output, CFN condition. CFN include is a particularly interesting one, and I'll talk about it a little more in a little bit. Basically, if you have existing CloudFormation templates, you can actually kind of import them into the CDK using CFN include. And so as you kind of work to refactor and adopt the CDK, you can keep your existing templates around and work towards breaking those down and codifying them instead. So that's 500 lines of CloudFormation. The big thing that does this, I can't do that, can I? The big piece here is this load balance Fargate service that stands up all kinds of pieces of ECS and Fargate infrastructure to, and VPC pieces, well actually VPC's up above, but I mean it basically just defines all of the infrastructure needed to build out a whole load balance Docker-based service, and to me that's pretty incredible. I mean, something that can give you that level of compression in terms of like how much I have to write to what it outputs, in terms of meaningful infrastructure. That's a big advantage right there. So cheat sheet on the CLI, install it from npm. We did not shut off notifications, did we? I'm just glad it wasn't anything embarrassing. Usually good about that. All right, so we can initialize a new application with cdn init, then you give it a language flag, CDK synth, or you can also use CDK synthesize, that outputs the CloudFormation, CDK deploy to shoot it out to the cloud. In the case of multi-stack apps, which we'll see an example here in a minute, you may also have to specify one or more stack names there. You can then, so the other thing, actually I didn't highlight this here. You'll notice that to do anything with S3, I actually had to pull in a separate module. So each service has one or more modules representing its resources. Now that may sound annoying, like, oh, well, if I'm building something that spans many different services, I gotta pull in all those. But on the other hand, that means the CDK package, the core CDK package itself is actually quite slim, and you're not pulling in any more than you actually need into your project. Which means, faster npm install times when it's time to spin up, when you're first pulling down that package. Listing the stacks in your app, CDK-ls. You can actually diff your current code against what's already deployed with CDK diff. We'll take a look at what that looks like here in a minute. And then tear down a stack with CDK destroy. It does prompt, so if you're doing this in an automated fashion, you can throw in a -f flag, and it'll no prompt enforce it. And if you need help, --help for that. There is a config file, which if you have it auto-generate one of the sample apps, they'll actually show you at least the bare bones of one of these. The biggest thing that this is helpful for, and I'm not going to go through any of the other properties of it, but this app property down here tells it what command to run the app. Otherwise, you have to specify that through the app flag, and this makes it a lot easier just having a CDK JSON. There's an order of precedence, CLI args override anything in your CDK JSON. The local CDK JSON for the project then is taken, and then you can actually specify one in your home directory with a dot in front of it, and it'll pick that up as well. So some advanced techniques. First one we're going to do is multi-region apps, and I actually have a demo for this one. So I have more meme bucket stack, and so what's more interesting here is the skeleton is really what's changed. I mean, I added the word more otherwise, but the skeleton here now specifies that I'm going to deploy to two different stacks, one to US East 1, one to US West 2. This is impossible in a single CloudFormation template, or even in anything that is just CloudFormation. You can't really define a concept of region. That's what you do when you deploy the stack. So the idea that we could say, within one application, one set of files and stuff like that, that all belong together, that we could say, I'm going to have a application that exists in these three regions, and these are the stacks going to these regions. You can even, in this env property here, you can even declare account IDs. So you can shoot stacks in multiple regions, in multiple accounts, all from one application, which is something that is just not even possible right now. With there are other tools, things like Ansible and probably Terraform can accomplish this, but none of those are AWS built, AWS blessed things. So if you're really trying to focus on things that have official support, this is the first time we've been able to do this. The other property here, versioning, was one that I added to it. And if we go look at the more meme bucket stack itself, I added a property in here that turns on and off versioning based on that. So we can add in additional properties or parameters essentially that can tweak how the stack performs. So, having seen that, let's CDK deploy that. So since it has more than one stack, I have to tell it which one I want. But wildcards are allowed, and they both start with M. So I'm deploying them both with M star. Now this is going to take a minute, so I'll let that go. And we'll talk about some of these other things and come back, because, so we can talk about multi-stack apps, that actually already covered it, but you can also have you can have multi-stack apps where the stacks aren't the same. And we'll see a slide a little bit later one of the coolest things about it is it can automatically wire up exports and imports if one stack references something in the other. And I'll show you like an example of how that looks in the code. Another one that's really cool is aspects. So, has anyone here ever heard of aspect-oriented programming? AOP? It's kind of a black magic. I mean, if you really know it, the depths of it, it's basically like having something that can kind of infect your entire application, like intercept, intercept every function call that's marked with this piece of metadata and do something before or after that function executes. Things like, so you can have automatic logging and things like that. It's kind of a dark art. Like I've seen it done in .NET, and some of the tools that do it actually weave their way into the compilation process and modify the IL. What is that? Something help what that stands for. Is it intermediate language?
Yep.
Okay. Yeah, it actually weaves function calls and modifies the IL that the runtime, that the .NET runtime actually executes. So it's pretty much black magic in my opinion. Like aspect-oriented programming is a really, really clever and interesting thing, and that's just sort of what happens here. The idea is, and we're going to see a slide on it in a minute, but now that this is deployed, I wanted to show you guys one of those. So those of you who are familiar with AWS know about tags. Tags allow us to basically just add metadata to things, to everything from S3 buckets to EC2 instances. Just about everything in AWS is taggable. We may want to do this to know, do we need, does this thing need to be preserved? What CloudFormation stack produced this? What part of our organization does this belong to, so we know who to bill it to? Which part, whose bottom line should this come out of? So cost control to inventorying things. What is the function of this server? Is it a jump box? Is it part of a load balanced group? What is it? So tags are an important thing there. And remembering to tag every single thing in a CloudFormation template is tedious, annoying, and repetitive. Well, with this one line here, I can tag everything, remembering what this is. In this case, this is the stack. I'm saying, on this stack, apply this aspect to everything, and that's a tag that says memes. And the value is all of them. But you can easily see how we would actually use this for like useful things. But if I do CDK diff, you can now see that when I do CDK deploy, it's going to go out there and actually add these tags to both of those buckets. Bit me again. There we go. All right. So let's go take a look here at this, and we can actually now see that my two buckets are out there, and on the one in US East 1, versioning is enabled. I don't know if you guys can see that back there. Take my word for it, versioning is now disabled. If you saw the thing change, at least. Hey, I can see. You guys see it now?
Yeah.
So, even our logical changes made it through there. Alright. Like I mentioned before, we can evolve our existing CloudFormation stacks by using CFN include, and if something's not defined, somehow this thing lags behind CloudFormation, you can basically pull in any CloudFormation type with CFN resource that's part of the core module. So it's kind of the last-ditch escape hatch, plus you can still use custom resources. Anything that CloudFormation could do, you can still do. There we go. So we talked about automatic import-export. This is an example of that. Stack 1 produces a bucket, and stack 2 here then actually references stack1.bucket. if you actually were to put, to build a reasonable piece of CDK code that did all of this and do a CDK synth, the output CloudFormation templates for stack 1 would actually do an export of that bucket, and the output CloudFormation for stack 2 would actually properly do an import value against that export. You don't have to do any of that here. So we didn't have to use CFN output, we didn't have to do any of that. Aspects we already talked about. Basically applies an operation to everything in current scope or in the given scope. We already talked about tagging in the example, but another interesting one is that you could really basically apply anything to it, and the linked example here I think is really cool. It actually shows applying a bucket versioning checker. So you're saying, I want to make sure that all buckets that this aspect is applied to, all of them have to be versioned. And if versioning is not turned on, we're going to add an error to the synthesis process, and basically when it's done, it's going to blow up. So if you can imagine, for a CI process, from looking at this from like a DevOps and especially dev, to use the even more cool new term DevSecOps point of view, if you're looking at this from a security point of view, being able to say encryption's on, public access is off, versioning's on, we're going to make sure that all these rules are followed. Okay, now these are our so make these kinds of aspects and go ahead and define your own version, your own defaults. Make these packages available inside maybe in a private NPM repo. There you go. Now your developers can safely build infrastructure as code using the languages that they already know, and you can feel better knowing that they did it correctly, basically. So. One of the gotchas, parameters. So if you're assuming familiarity with CloudFormation, parameters aren't supported by the CDK, but I don't see this as a problem. I actually see it as it cuts out a middleman, because most of the time, if you had a parameter and you were doing CI, all you were doing was pumping an environment variable through a parameter into your template. Well, now I can just go process, if we're talking about Node, TypeScript or either TypeScript or regular JavaScript, process.env. Whatever my variable is. I've just cut out the parameter. That's a problem. So, problem solved. Have a drink. Move on. Now, actually, there's a couple other things that you do. Let's say you had something where you still needed to work with parameters. You could do CDK synth, get your output CloudFormation template, and then anything that normally would have worked with CloudFormation still works. So you can still define parameters, you just need to go an extra step so that you actually have a template that you can deploy that way. You can also use SSM and Secrets Manager if you need secrets kept encrypted at rest with KMS keys or however you want to do that. Those can be imported. I actually linked to an issue where people were griping about the fact that this thing doesn't support parameters, and the people designing this were pointing out that's not really the design philosophy behind this. You should be able to directly influence this because you're running an application to generate the CloudFormation, basically. Your parameters should no longer be necessary. So, RIP. We're getting here just about to the end of this. We talked about SAM and its higher level constructs. We talked about how the CDK has higher level constructs. The function within the Lambda module is not unlike SAM's serverless function. And it's closer to that than a raw CloudFormation resource. So, got an example here where this one bit of CDK code will create a Lambda to access an encrypted bucket, allow an execution role for the Lambda, attach the policy is necessary to write to CloudWatch, access the S3 bucket, and access KMS, and update the KMS policy for access to Lambda. And that's all it takes. As opposed to the massive amount of CloudFormation that you probably would have had to write to do all that. So the big pieces there, we're enabling the encryption, the Lambda function, instead of having to piece together its role and all the other various parameters, we can even link to a code asset that's referencing a local folder full of functions and stuff, and so that can go ahead and grab that and upload, zip that up and help us upload that in the process. And then this is probably one of the most interesting pieces of it. This is where we talk about, from the permissioning point of view, we needed to allow the Lambda access to the S3 bucket. Well, the bucket can actually do the grant. You can actually, off the bucket, do the grant of read and write to the Lambda role. And that, I think, is probably one of the most mind-warping parts of this. If you've worked with, especially for like a lot of AWS concepts, like the idea of not having to go and say, I need something from IAM to do this for me. They're actually enabling the individual constructs to grant access in certain ways. And that is flipping some of it on its head, but it almost makes more sense this way. That's all I got, actually. For once, a talk of mine that didn't go forever. Thanks for listening. Do you guys have questions, comments? I don't know. I don't know the sorry, go ahead.
Yeah, so when you're running it as the AWS logged in user. That's who's running that, who's executing the CloudFormation.
Correct.
So if you have a CDK that's across two accounts, how does that work?
That's a great question. I haven't explored that one.
Okay.
That's one of the reasons why I don't have that example yet. I have that question. I actually gave this talk to our team today at lunch. I went through that first part really quick because we all already know all of that, and this being a broader audience, I wanted to give people a better background to things. But that exact same question was asked, essentially. So I don't have an answer to that one as far as like, because usually the way we do things, you'd assume a role into each account and stuff like that, and I don't unfortunately have the answer to that one at this time. I've gotten a chance to broadly investigate the CDK, wrap my head around how it works, pull together some examples, actually get it working, see some of the more interesting things like the fact that I could do multi-region deployments out of a single thing, multi-account deployments, the aspects piece. Those were all just mind-blowing from the point of view of like, I thought this was just going to be, I can write JavaScript instead of YAML, and I'm going to get my stacks still. This far exceeded what I was expecting, but unfortunately I don't have the answer to that one. So, and that may still be something that they're working on. I mean, this, while it's generally available and certain pieces of it are highly stable, there are definitely parts of it that are still in beta, still sort of in preview. So, I mean, there are even Java and .NET Core support aren't even GA. So, it may be something that's still coming too. I don't know the answer. Sorry, but hopefully this is one of the things if nothing else, hopefully this gives you enough background on it to be able to dive into the docs and get there quicker.
For existing infrastructure that you have that there's no CloudFormation or stack for at all, is there any entry point for like grabbing that infrastructure and automatically creating?
That's a problem across the board. You can't even do that really with CloudFormation, unfortunately. That's the question was asked of me earlier today. Could you bring in an existing stack at least? And while I know that you can bring in an existing template and then deploy it, that is probably outside of the realm of possibility. What you're asking there. What I'm not sure on myself is what happens if you try to grab an existing stack and fold it into a CDK app. That may be possible. I think it'd be an interesting experiment, but bringing existing infrastructure that's been defined outside of the CloudFormation template just doesn't work, sadly. No, it's a known limitation of CloudFormation alone. So, and with that being the underpinnings of this, I would expect it to be just as impossible. So, other questions?
Do they provide a unit testing framework or harness, or are you just writing your own like Mocha tests?
You'd be using Mocha if you're in JavaScript. I mean, given that they're doing broad language support, they've provided no specific thing there. I think that's more of a bring your own, pick your own. You know, each language has their own way of doing that. Even multiple. I mean, I remember doing NUnit and MS Test both in C# back in the day. I don't know what's available now for .NET Core, but you know, even JavaScript. There's I'll say there Mocha, Jasmine, Jest. What was that one I used? Ava as a test runner. Although that was a runner, I think you can still use Mocha with it. I can't remember. It's been a minute. But I mean, so the number of testing frameworks out there, I don't think they want to be prescriptive necessarily in that regard. Although I'm trying to read their minds. So. Their focus here seems to be more on one, making the core idea work, but the other thing that that kind of became apparent to me as I read through the docs and kind of wrap my head around it, especially like things like the automatic export import and the way the aspects work. They didn't just write something that translates some code one language into another. They actually are tokenizing and figuring out that this is much closer, this feels much closer to a compiler just looking at the documentation and what it's capable of. It's able to actually understand how things got connected together and then infer what needs to happen from there without you having to tell it. And so there's definitely some magic going on. You know, not really magic, but feels magical from the point of view as a developer writing this. Way more powerful than I expected.
Okay, so if you were to hook this into a CI/CD pipeline, things like S3 buckets aren't going to get recreated every time, but an EC2 instance, would you maybe spin up a new one for the new version? You update Route 55 to point to the new version, and you know.
It's worth remembering that the CloudFormation side is potent, so you're not going to necessarily you're not recreating buckets or instances or things like that generally. Only if you've added or removed things from the actual configuration would you be spinning up new instances or removing instances. I've noticed that they automatically retain buckets. I don't know if you guys saw that in the output CloudFormation. That's probably worth taking a look back at. I can find that synth output. They actually put, that's not looking for you guys. Just you guys know about where I was at now. They actually add in update and deletion policies that tell it to retain S3 buckets, which is a known issue. And once an S3 bucket has data in it, you can't delete it when you're deleting a stack, and that's kind of what. But I mean, that's because they don't want you accidentally deleting data that might actually be valuable. So, yeah. So I'm not sure if I actually answered the question there. Off track.
How far up does the automatic figuring out what needs access to what? Like, can I say this instance is going to have this service that needs to talk to this, like a custom service that I've written, it's talk to this custom service, and I only want like stuff egressing on like from this IP to that IP, like on these ports. Like, is that to that level?
That's a really good question. It's beyond the scope of how far I've gotten into it.
Because like really fine grain, you know, access control. That would be really interesting if we were able to.
I mean, you have to tell it enough that it just. I think the bigger thing that they're taking care of is like figuring out the references and what would need to be, imported, exported between stacks and things like that. Yeah. One of the things that's worth looking at in the documentation there is what they're doing with, like, look up, there's a section, actually I'll pull it up. In the developer guide. Concepts, here we go. Under concepts, there's this page on tokens and stuff like that. So like if you actually print out from your app, like if you logged out the bucket name, it actually spits out something like this. And it's not the bucket name because we don't know, especially if you haven't named the bucket explicitly, then it's just gonna generate, automatically generate that name. And in this case, it's not even showing us the auto-generated name because that's something the service itself does. This is just a token representing that reference. So, there's a lot that it seems to be able to figure out and wire together and then it fills in the correct ref values and things like that when it gets to generate the CloudFormation, but it still leaves it up to CloudFormation, the service itself, to resolve those references and name those things. None of that happens through the CDK itself. So, again, I know it's not directly answering the question, but it gives you some idea of kind of an insight into how it works on the inside. Anybody else? Anything not make sense? No? Bueller?
Anyway.
That's all I got.